Hi students, a very pleasant and warm greetings to you all. Hope you are doing good. Last session we have seen about decimal to binary conversion and now we are going to see decimal to octal conversion. Okay. As we have seen in decimal to binary conversion only, here also same method, only the thing that differs is the base number, right? Here decimal to octal conversion also, here we are going to divide the number repeatedly by 8, okay? Here octal means the base is 8, so as we have divided by 2 for determining the binary number, here we are going to repeatedly divide by 8. Okay, this method can be used to determine the octal number from a decimal number. Okay, this method is the same only as we have learned the decimal to binary conversion. Let's see an example. Same 65 they have considered here. 65 will divide with 8. 8 means first step. What they have done? 8. 8 into 8. They have divided by 8. So 8 times, right? 8 8s are 64, right? So here one balance will be there. So here 8. And again, next time again, when you are dividing it by 8, the answer is 1 and the remainder is 0, right? So here the octal number for 65 is 101. Okay, understood? Here we are dividing by 8. 64. When 65 is divided by 8, we will get 8. Okay, and remainder will be 1. So 8 hyphen 1. And again, if 8 is divided by 8, answer is 1 hyphen 0. Okay, so the value is 101. Okay, same way only for hexadecimal, we have to divide it by 16. Okay, we have to divide it by 16. Okay, in the same way only, in converting to binary, we have divided with 2. 2 is the base number for binary. And for octal conversion, we have divided with 8 because 8 is the base for an octal number. And in hexadecimal means hexadecimal base value is 16. So we'll divide it by 16. Right here, we have given one example here, 31. 31, when you are dividing it by 16, the value will be 1 only. And the balance is 15. Okay, 15. So you will put 1 hyphen 15, right? 15 is the LSB, least significant bit, and 1 is the most significant bit, right? So you'll just write 1 and 15. 15 means you know what is the 15 value? F, right? Yesterday we saw a tabular column, right? There you have seen hexadecimal values 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F, right? So 10 means A, 11 means B, 12 means C, 13 means D, 14 means E, 15 means F. So here we have got 15. So the value is F, right? 1 and 15. 15 means in the place of 15 we have to mention F. So the value that is 31 means here the value is 1 F. Okay. So today we have learned the decimal to octal conversion and decimal to hexadecimal conversion. Next we are going to see about conversion of fractional decimal to binary. That means fractional means we know pointed numbers, right? So pointed numbers means we'll have two parts. We'll have a number before the point and after the point, right? That is the fractional decimals. Okay, so today we have learned about converting the decimal to binary, decimal to octal, and decimal to hexadecimal, right? So this is easy. Decimal to binary means you'll just divide it by 2 and you'll take the remainder and you'll be getting the binary value. Decimal number to octal means you'll just divide the decimal value by 8 and you will just take the remainder and write it. That is octal number. And decimal to hexadecimal means you'll just divide the hexadecimal value by 16 and you'll just take the remainder and you'll put it, that is hexadecimal number of that particular decimal number, right? Now we are going to convert the fractional decimal to binary. Okay, this method of a repeated multiplication by 2 has to be used to convert this kind of decimal fractions. Okay, here some of the steps involved are: first you have to multiply the decimal fraction by 2, and you have to note the integral part. Here you will have two parts. First you are taking only the integral part. The integral part will be either 0 or 1. Okay, first you have to multiply the decimal fraction by 2 and note the integer part of that uh, value, right? Where first you are noting the integer part, and the integer part will be 0 or 1. Okay, and then discard the integer part of the previous product, and then multiply the fractional part of the previous product by 2, and again you have to repeat the first step until the same fraction repeats, or it will terminate, or it will give the value 0, right? And then the resulting integer part forms a sequence of 0 and 1 that will become the binary equivalent for that particular decimal fraction. Okay, the final answer has to be returned from first integer part obtained till the last integer part obtained. Okay, here you can see and you will get the idea. See, here they are given an example: 0.2 into 2, right? So here if you see, first you are multiplying the fractional decimal fraction by 2, and then we are noting the integral part, integer part, right? This integer part is 0 or 1, right? And then we are discarding the integer part of the previous product, right? And then multiply the fractional part of the previous product by 2, and again you are repeating the first step. What is the first step? Multiplying the decimal fraction by 2 and note the integer part, and the integer part will be 0 or 1, right? You will have to repeat it again and again till the last integer or the value ends, that is till we get 0. Okay, here if you see 0.2, right? 0.2 into 2, 0.4. So we have taken the integer part, and that value is again multiplied by 2, and we'll get 0.8. So again we'll take 0 there, and 0.8 into 2, 1.6. Right? So here you will get integer part is 1. So the value is 1. And again 1.6, you'll just take the integer part there, and you will just leave the integer part. So you will get 0.6 into 2, that is 1.2. Again you will just take only the integer part there, so it is 1, and again you will delete the integer part, and the value will be 0.2 into 2, that is 0.4. So here we will get 0, right? Last integer part obtained is 0, right? So the value is 00110, right? So here the fraction repeats the product is the same as the first step only. The fraction will be repeated. The product is same as the first step only, right? Here now we have to write the integer part from the bottom, top to bottom, to obtain the binary value. Okay, so 0.2 means the value is 0.00110011, right? That is 0.00110011. Okay, so this is the way to convert a fractional decimal to binary. Okay, binary to decimal conversion means first you will have to write down the binary digits and the list of powers of 2 from right to left position. That means here you can see the positional notation and weight here. For each positional notation, we'll write the equivalent weight there, and then multiply each digit with its corresponding weight, and we'll at last we'll add all the values. Okay, here positional weight means 2 power 0, 1, 2 power 1, 2, 2 power 4, 2, 2 power 2, 4, 2 power 3, 8, 2 power 4, 16, 2 power 5, 32, 2 power 6, 64, 2 power 7, 128, 2 power 8, 256, 2 power 9, 512, 2 power 10, 1024, right? And now we are going to convert this binary number into its decimal number. Okay, to convert, first you are entering these values here. Okay, the given number is 111011. Okay, the weight also you have to mention here. You know the weight for we have 5 values here, right? 5, 1, 1, 1, 0, 1, 1. So you have 6 values here. So it will be 2 power 5, 2 power 4, 2 power 3, 2 power 2, 2 power 1 and 2 power 0. 2 power 5 means it is 32. 2 power 4 means it is 16. 2 power 3 means it is 8. 2 power 2 is 4. 2 power 1 is 2 and 2 power 0 is 1. Right? So from that value, you will consider 2 power 5 into 32, like that you will be considering, right? 2 power, see here, for 1 1 1 0 1 1, like that. For this value you are going to determine the value there. So here we'll get 32 plus 16 plus 8 plus 0 plus 2 plus 1, right? So the value is 59. So the binary value for 111011 is 59. How did you got 59? First you will write the positional values and then the values of that position. 2 power 0 means 1, 2 power 1 means 2, 2 power 2 means 4, 2 power 3 means 8, 2 power 4 means 16, 2 power 5 means 32, right? So here, wherever 1 is there, you will just add it, right? 32 plus 16 plus 8 plus, in that value we have 0, so we have left that value, and then 2 plus 1. So the value is 59. Okay. So we have seen the conversion of fractional decimal to binary, and also we have seen the binary to decimal conversion, and in the next class we'll see the binary to octal conversion and binary to hexadecimal conversion, and after that we'll be learning the conversion of fractional binary to decimal equivalent. Okay, fractional binary to decimal equivalent means the same as we saw in decimal numbers, only point numbers will be, decimal point will be there, and before and after the point the values will be there, right? We'll see that in the next session. So before moving on to the conversion of fractional binaries and all, we just be thorough about this number system conversions. You must be thorough with converting the decimal to binary numbers, and decimal to octal conversion, decimal to hexadecimal conversion, and also conversion of fractional decimal to binary, and also the conversion of binary to decimal conversion. Okay, so so next session we'll see the conversion of binary to octal numbers. Okay, this is also easy, only same like as we saw there. We'll see it in the next session. Okay, before that you just go through the portions which we have seen today. It is till page number 19. Okay, in second chapter till page number 19, you just make it thorough. If you have any doubts, you can ask me, or you just refer your book and you just try it on your own. You just take any one number, 95 or 65 or 68, and you just try to convert it to binary, and you can just take any one binary number and you can convert it to the decimal, or to the octal or to the hexadecimal and all. Okay, so next session we'll see the next conversions. So be thorough with today's portion. Thank you for your valuable time. Stay home, stay safe, take care, bye.